Today we are taking a look at inverse functions. With this warm-up, maybe you noticed that from what you may remember last year, okay, we have two functions. F of x is x plus 2, and g of x is x minus 2. All right. These are two very basic functions, right? And you can kind of maybe see already that they are inverse, right? We're doing the opposite operation to our x. So I wanted you to find two composite functions, okay? First f of g of x, and then flip it to g of f of x. So let's go over that real quick. So for our first one, okay, remember the way that we were doing it in class, you're going to replace the inside. If you don't have a number here, if you had a number here, you would plug it in right away. But if you don't have a number, what you're going to do is you're going to replace g of x with what it actually is. So you're going to have f of x minus 2. So again, this is telling you that you're plugging in x minus 2 into the x up here. So you're going to have x minus 2. And then what are we doing to f? We're taking whatever we plug in and we're adding 2. So plus 2. So when we simplify this, we have a negative 2 plus 2, and we're left with x. Now, if you went over some of the problems, last week, these two aren't always necessarily equal to each other. Okay, if you had two functions that were unrelated, okay, maybe some polynomial and then some square root function, these two wouldn't guarantee you get the same answer. And you may have seen that. I'm not sure if we did it with numbers. Okay, so if you did f of g of 1 and g of f of 1, you may not end up with the same thing. But in this case, all right, we're going to do the same thing we did over here. I'm replacing f of x with the phrase, right, the expression. So you're going to have g of x plus 2. Again, just like before, we're going to take this x plus 2 and plug it in there. So we're going to have x plus 2. And then from that, we're going to minus 2. Again, they're gone, and we're left with x. Now, this is important because we'll actually see that later. All right. So last week, we talked about inverse functions. And how we represent them, right? We show an inverse function with a -1 exponent, okay? But be careful, this isn't like we usually see our exponents, right? Okay. We do not treat it like a normal exponent, okay? It doesn't mean that we do 1 over f of x, right? Because if you had x to the -1, that would be 1 over x, right? That's our rule for exponents, negative exponents. But this is more just a name than doing an operation, okay? So we're not flipping our function like that. We're not doing 1 over the function. Okay, so first we'll do a basic rule. So if I have some function f, what we saw, right, was you have the domain functions, right, all your x values. You plug in f of x, and you get your range. Actually, I'll call the range y in this case. And that's how normal functions work. When we have inverse functions, you're taking the range of the original function, and it gives you the domain. Right? So when we saw, like, when we first started talking about, is this a function, and we mapped, our x values to our y values, the inverse function does the opposite. It takes your y values and it matches it to your x values. So if we're looking at coordinate points, okay, right? So all your x values are your domain, 1, 2, 3, 4. Your y values are your range, 5, 6, 7, 8. Without even knowing what the function is, now this function, could be anything. Our most basic one we can see is I can do x plus 4, right? 1 plus 4 is 5, 2 plus 4 is 6, 3 plus 4 is 7, 4 plus 4 is 8. But without even knowing that, if I was given this information, I could find the domain and range of my inverse function by swapping my domain and range. So there I would have 5, comma 1, 6, comma 2, 7, 3, and 8, 4. So you don't necessarily need a function to find the inverse. Okay, if you're given a set of its domain and range of its coordinate points, you can flip the x's and y's to find the inverse. Now that's not super mathematical, right? You're just switching numbers around. So let me give you the definition. Okay, so a lot of these definitions and stuff from here on out, you'll see me say something like let f and g be two functions. That's just, it's kind of like setting a basis. So they're just saying f and g, are two functions. That's where we're starting off with. So, so such that f of g of x equals x, and g of f of x equals x. I don't know. Okay, so if we see this condition where we do a composite function and our answer after we simplify is just x, okay, and it's the same for the reverse where we do g of f of x, then we can officially say that g is the inverse of f and can be denoted f to the negative 1. Okay, and this is a side note. Okay, so again, I said this, above here. The domain of f must be equal to the range of the inverse as well as the opposite. Okay, which means the range of f must be equal to the domain of the inverse. So I'll give you a second if you got to finish copying anything down there. Okay, and I'll go over one more example where we do the composite. Okay. Okay, so here we're going to prove that g of x, which is x minus 4 over 7, and h of x, which is 7x plus 4, are inverse. Now we're going to do this algebraically, so we're going to plug in, okay? Because it would be too much to try to, prove that the domain of this is equal to the range of that. That's just too many numbers. So we're going to do our composite function problem. So first, we're going to find g of h of x, and then we're going to do h of g of x. So here, okay, what we're doing is we're plugging in h of x, which is 7x plus 4, into g. So you're taking the 7x plus 4, it's going here into the x. So you're going to have 7x plus 4 minus 4 over 7. Our 4's cancel out, plus 4 minus 4. We're left with 7x over 7. And what do you know? Those two cancel out. We get x. Off to a good start. Now we're going to do the opposite. I'm going to take my g of x, which is x minus 4 over 7, and I'm going to plug it into h. So we're going to have 7, right, because that's on the outside, times x minus 4 over 7 plus 4. Here we're multiplying by 7 and dividing by 7. So they're eliminated. X minus 4 plus 4, well, that's pretty straightforward. And that gets us x. All right, so they both equal x. So we can say g is okay, or you can say the opposite. H is the inverse of g. Either one will work. All right, with our last, we still got time, 12 minutes. We're going to look at the graphs. So let me get this up. So something happens special with the graphs, okay, and it has to do with this result. Okay, when we have this tells us, okay, we'll say okay, that line, or the resulting formula, y equals x, is our line of reflection for inverse functions. All right, let me see. All right, so we'll deal with a basic function. So let's say 2x minus 3. Let me do something else. Let me do actually, let's stick with, let me do another one. Here we go. This is what I was looking for. Okay. So here, I'm going to show you a demo first, and then you guys are going to practice this. So here they give you this red line here. We want to find the inverse to this red line. So remember, one of the things that we can do, if we go back, is we can switch our domain and our range, our x's and our y's. So here, our 1 point they give us is 1, 0. So the inverse of that would be 0, 1. Okay, so I would put that there. But then I need to find another point, right? Because that's obviously not the inverse. So we find another point. Okay, so I'll do maybe 2, 1, right? So the 2, 1 is a point that is on my original line. So the opposite, I would go to 1, 2. So here we have, two parallel lines. It just so happens that that's how it works. Let's take a look at one more before I give you one to do on your own. So here they give you the point 3, 2. So you're going to flip that, and you're going to have the point 2, 3. Okay. Now, let's go to another point. Up here we have 6, 4. So you're going to switch the x and the y. You have 4, 6. Now here, this is a little clearer, okay? If you had a line equals x, okay, it would go straight through here, right? And then you would have 2 reflections. So with our remaining time, I'd like you to go to geogebra.org/classroom, and then you're going to type in this code. All right, so everybody, please do that now. And again, www.geogebra.org/classroom. And then your code is N79T FMGM. Don't forget the space. All right, we got one. I'm going to put it in our chat so you have it there too.
I'm so confused.
What's up?
Not like with this graph.
Give me 1 second. All right, so I put the information in the chat just in case because I'm going to go over here. Okay, so I'm taking a look at what you got there. All right, so again, the red line is your original function. So what is a coordinate point on your red line? What is the one coordinate point they give you?
5.
5 what? 5 comma
6.
6. Okay, so right, the x comes first, then the y, 5, 6. Now what you're going to do is you're going to flop those. So now you're going to plot the point 6, 5. Okay, but that's 1 point. You need to find another point now. So where else on the graph do you see a nice
Negative 5, 0.
Say it again, I'm sorry.
Negative 5, 0.
Okay, good. So negative 5, 0. So when you do the inverse of that, what is your point going to be?
0, negative 5.
0, negative 5. Okay, and actually here, this dotted line is your line y equals x. So you can see it's a mirror image. It flips over the diagonal there. Okay, and that's what the show hint does. All right, so try a few, and then once you're done, you can click on the new problem and try a different one. There we go. All right, so try. Oh, good job, Barbara. You got one correct there. I'll hide your names. Student 4 left. We only All right, so try out a few there. So what we're going to do tomorrow is we're going to take a look at some larger functions, not just linear ones. Nice, nice.
Wait, my name didn't pop up because it says I'm in.
I'm not seeing you. You're doing the task right, like you're moving points around.
Oh, never mind. That's what I have to do.
Yeah.
So like, okay.
Once we do like that first one, how do we go on to the next one?
You'll see on the bottom left corner a green box that says new problem. Click that.
Oh, okay. Sorry.
That's okay. Just a quick survey. Would something like this, with this interactive stuff, do you guys like this, or would you just rather me do like the lectures that I've been doing, the notes and stuff?